a representative has many voters that vote for that representative. And the representative gives to the voters a unit of representation. So you could just draw that as a block. And if you have many representatives all representing a group of voters, then you could represent the voters, one each along this line, and maybe this representative represents these two voters, and this one for these two, and this one for these two. The representative, each representative has the same amount of representation in the legislature, so they are able to give the same amount of representation to each of their voters. In this case, this representative gets divided into two units, and one goes to this voter and one goes to that voter. And you can see that this method of assigning representation is proportional because each voter gets the same amount of representation. That's what proportional means. Proportional representation means, it's as opposed to a single winner method. So in a single winner method, these voters, some of them may not like a representative. So really the representative only represents this part of the voters. So these guys got 0 amount of representation, and these guys, they all got 1 unit. And I'm not really paying attention to much of the units here, just saying that 1/4 of this representative would be paying attention to each of these voters. So that's the idea of proportional representation. So that's pretty much a good explanation. You could just stop there, but I think I'll go further because we want to see how a whole election turns out. And there's an algorithm to decide which representatives should be chosen for that particular election. Okay, so we have this idea that voters are along this line, and there's a set of representatives, and if they are chosen, then they can represent certain sets of voters. So in this case, say you were choosing 2 representatives out of these 3, representative A, B, and C. If you were picking 2 out of 3, you would pick this one and this one, because that would give the most representation to the most voters. I mean, it would spread the representation. And what you're really trying to avoid is that some people will not be represented. So say you picked these 2 instead, then these voters would get twice the representation as these voters. So if you were to graph the amount of representation each voter got, it would look kind of like this, with 0 out here. So it actually seems that you want to kind of squash that down. The same amount of representation would still be there, but if you squash that down, then you could have like picking the first example, like in this case, you have pretty much you've minimized this height here, you've brought it down from this level to that level. And this is just like, you know how you use algebra to describe what's really happening? This is kind of like that. You know, you don't really get what's going on immediately by just doing algebraic manipulations or moving around these bars. But the idea is, going back to the beginning, that each representative gets the same amount of representation in the legislature, and they can give that representation to each of the people that voted for them. So that's the basics of how an election would turn out, and what would be more fair. It would be more fair if the representation was given equally among everybody. And there's probably other examples you could use too. But that's this little minimization process, or spreading out process. That's basically what a good proportional representation algorithm should do. That's kind of the goal. So I've just kind of described the goal of a proportional representation algorithm. So now I think I'd like to describe like the actual algorithm rather than just describing what it should do. So say you have a number of ballots, and if you had an approval style ballot, you would have each voter say whether they're going to be represented or not represented by a candidate A. So these voters over here are not represented, and these voters over here are represented by A. So in an election, you would have something like this, where you have voters kind of voting in blocks, and maybe there's actually another candidate that's more widespread. But let's just go with this example. So I'm going to show how an actual election algorithm would work. So say you first look at who has the most votes and get that person in. So maybe this length here for A is bigger than the other lengths. So that means that they have the most voters down here. The sum of this number of voters is greater than the sum of this number of voters. So choose A, or elect A first. This is an iterative process for this algorithm. I'm just describing the reweighted range voting, or proportional approval voting. I forget actually the name of it, but I'll just describe the algorithm and then you can figure out what it's named afterwards. So after these guys, these guys all got their representative, right? So they're pretty much done. But there's a lot of other people here that were not represented. So look at just these people that are not represented. You'll see there's a few votes for this guy and a lot of votes for this guy. So this guy would be the next choice. So then you choose C. So that's pretty simple, right? So that's just how you would actually run an election. You have people vote. They are able to vote and support however many candidates they like. So like, for example, this voter chose 2 candidates that they liked, and this voter only chose 1. And then once maybe you could get a better algorithm, but this algorithm just picks the guy with the most votes first, and then fills in with the rest of the voters to find who has the next most votes. So that's pretty much a proportional approval algorithm. Pretty simple. I think it's pretty easy to visualize, and this would be a good explanation for people that are unfamiliar with proportional approval voting. There are other situations you could describe, but this is pretty straightforward. No Excel sheets or spreadsheets needed, just a good visual example. So this would be pretty good to introduce people to the concept.